Okay, we've got our two-dimensional forces exercise here with a hanging sign. With a hanging sign, we know that it's not accelerating, so we've got balanced forces. All the upward forces equal all the downward forces. All the leftward forces equal all the rightward forces. I usually break my forces that are at angles into their horizontal and vertical components first, so that I can then create my summation of forces equations, my net force equations. So I've labeled T1 on the left, T2 on the right. My T2 has a horizontal component that would be T2 cosine 60 because I brought that angle down. And then the vertical component would be T2 sine of 60. I'm going to make my net force equation saying that the leftward force, there's only one, is equal to the rightward force, in this case also only one. Two variables require two equations, so I'm going to say my upward force, I only have one, T2 sine 60, is equal to the downward force, force of gravity, here labeled mg. There is no force normal because there is no surface this sign is sitting on. The second equation does allow me to solve because I know mg is 100 mass times 10. So I just rearranged the equation and I divided the sine of 60 to the other side. In degree mode in my calculator, I put 100 divided by open parentheses sine, it opens another parentheses 60, close parentheses, close parentheses. When I did that, I got 115.47. Our numbers will be pretty close. If you're a little bit different, it could be based on rounding. If you found the sine of 60 first, and then you took an abbreviated form of that, rounding to two decimal places, and then divided that over. Of course, that's acceptable. Going back to our original equation, since we know what T2 is, we can say that T1 is 115.47 times the cosine of 60. So then T1 would be 57.74 newtons. With all of these, we're always breaking our forces into the components, horizontal and vertical, and then writing our net force equations. Generally, you'll have two equations with two variables, two unknown variables. Scrolling up, we can see that we've got a block of mass 8 kilograms being pulled by a string with a force of 50 newtons that makes an angle of 20 degrees above the horizontal. So go ahead and put that mass in the center because it said kilograms, so we know it's the mass. If it said 8 newtons, we would know that'd be the weight or the force of gravity. Let's go ahead and put that 50 newtons up and to the right. There's a component of that is to the right. There's a component that is to the upward direction. We'll go ahead and break that all down so we can see it. I use the dots for the components. Helps me keep things straight. Horizontally, that is the adjacent to the angle. So that would be 50 cosine of 20. Vertical is on the opposite side, 50 sine 20. Since the mass is 8, we know that mg, or the force of gravity, would be 80. Kind of broken things down into where we can see it. Force of friction would be to the left, force normal up. This is a block on the ground. It asks us to draw a free body diagram for the block, so let's go ahead and draw one based on getting points for a free body diagram. What I've drawn so far would be how we understand the problem, but how we do it on a test is different. It's from a dot, mg's down. Our force of tension's up to the right. Our force normal is straight up for this particular problem, and force friction is to the left. How much of the 50 Newton force is in the horizontal direction? The horizontal component of the 50 Newton pull is calculated as 50 cosine 20. In degree mode, from my calculator, I got 46.98 newtons, of course. How much of the 50 Newton force is in the vertical direction? Vertically, that's the up or down. I have it calculated as 50 sine 20. 50 sine 20 in my calculator. In degree mode, I got 17.1 newtons. What is the normal force on the object? Again, this is an object that is on a surface. Vertically, the forces are balanced, so I know that all of my upward forces equal all my downward forces. So force normal plus the y-ward component of the force of tension is equal to the downward force of gravity, mg. If I subtract force tension to the other side, I get force normal as mg minus force tension from the y. Or I've got force normal as 80 minus 17.1. Calculations I have above. So 80 minus 17.1 would get me 62.9 newtons. 62.9. What is the force of friction acting on the block? Don't forget the force of friction is coefficient times force normal. The problem told us that the coefficient was 0.2. We calculated just previously the force of normal is 62.9. So we're just going to take 0.2 times 62.9 and put it into our calculators. I got 12.58 newtons. What is the acceleration of the block? We know acceleration from Newton's second law of motion. Acceleration is net force divided by the mass. This block is not accelerating vertically. Most definitely it would accelerate horizontally. So we're going to take our horizontal forces. We calculated the horizontal component of the tension was 46.98. And we said friction that opposes the motion is 12.58. So we subtract them. They're going in opposite directions. And we divide that by the total mass. When I did that, 46.98 minus 12.58, and my calculator hit enter, divide that answer by 8, I got 4.3 meters per second square, and that would be to the right. Is it necessary that I wrote to the right? No, but I want to at least acknowledge that I know the direction and keep in mind that I do know that forces have magnitude and direction. I don't want it to get lost. Yes, we do use positives and negatives, but just trying to keep it straight. Now we're doing a problem that has a mass on an inclined plane. So let's go ahead and identify gravity goes straight down. Force normal is perpendicular to the surface. So there's a component of gravity that balances force normal. There's a component that would take you down the inclined plane. So let's look at that inclined plane itself. If that surface that I'm bolding right now is the inclined plane, what if we were to turn our heads to the left so that we saw that inclined plane being level? So that's what I'm going to draw now. That inclined plane is a level surface. My 8 kilograms goes in the center. Now force normal is going to go straight up. Force tension would go straight to the right. But then as we turn our head, instead of gravity going straight down, mg is kind of going down to the left. It is just perspective, it's nothing else. But this allows me to see that vertical component of gravity actually being vertical and the horizontal component of gravity actually being horizontal. Now we've broken things down into forces that are up and down, left and right, instead of everything being up and to the right, up and to the left. Now it says draw a free body diagram of the system. The free body diagram is still from a dot. Gravity is always down. We don't change our perspective when we're looking for points. We can change our perspective when we're trying to understand a problem. So tension is still up and to the right, normal still up and to the left, and they are perpendicular of each other. But mg is always straight down. Is the normal force acting on the mass greater than, less than, or equal to the weight of the block? Explain why or why not in a short paragraph. Well, look at my free body diagram that's kind of at the top, being cut off a little bit now on the screen. Is force normal balanced with mg? Or is force normal balanced with a component of mg? Isn't it just a component? A side that is smaller than the hypotenuse? So it's just a component, it's going to be something less. So we know the answer, but we got to ask ourselves why. And then maybe why again, so that we start with a physics fact, then we apply the fact to the problem, then we answer the question with our final sentence. Bullet points are the easiest, but if you love paragraphs, go for it. This is what I have. Balanced forces result in a constant velocity. Sounds like a physics fact to me. Sounds like it applies to this problem. The block is not accelerating vertically, and therefore vertical forces must be balanced. So I've applied that fact to this problem. Finally, force normal is balanced with the vertical component of gravity, calculated as mg cosine theta. This demonstrates force normal is less than the weight of the block, because I'm basically saying that it's balanced with just a component of the weight. It could have been written a little bit shorter, but I also wanted to make sure that you understood where I was coming from, the thought process behind it, and the approach. All the components are necessary. Start with a fact. Tell us how that fact applies, and then give an answer. usually thought of as what's the answer? Well, why is that answer? And what does that have to do with anything in physics? And that gets you the fact, the application, and the solution. It's the best well-rounded answer, and it'll ensure you get all of the points along the way, both on the unit test and on the AP exam. What will happen to the tension in the string as the angle is increased? Explain a short paragraph. Well, put your backpack on the desk, hold on to the strap. Is the tension really pulling against you just yet? Is there any tension at all? Well, if you start tipping your desk and your backpack starts to slide, the more you tip your desk, the more you're going to have to hold onto that cable, not the cable, but strap, right? Tension will have to be greater and greater to keep your backpack from falling. If you let the desk tip far enough, then all of the weight will be opposing the tension, and it would have gone from 0 to full weight. So we can see that tension is going to increase as the angle increases. We know that's going to happen, but why? And what does that have to do with physics? Well, let's start with a physics fact. Balanced forces result in a constant velocity. We do have a constant velocity. The velocity is 0 now, right? Well, what about now? Still 0? What about now? Still 0. It can be a non-constant, non-zero constant velocity, but here it's a constant velocity of 0. So we've got balanced forces result in a constant velocity. Increasing the angle will cause a larger portion of gravity to pull against the tension. mg sine theta, as theta increases, so will mg sine theta. In order to maintain a constant velocity, tension then must increase because the component of gravity it's balancing is increasing, so tension must increase to maintain that balanced force.